All right, so now looking at number 2, which is all scientific notation. So we have a number, 1.2 times 10 to the negative 3. The first thing to note here is that this number right here is a very small number because you're multiplying times 10 to the negative 3. What that really means is 1.2, if I'm multiplying times 10 to the negative 3, I'm taking 1.2 and I'm going to be dividing by 10 3 times. So I'm going to be taking this decimal and moving it over. 1, 2, 3. So this number in standard form is going to be 0.0012. So just to give you a little primer on scientific notation, that's a small number. And then when we look at other numbers that are times 10 to the positive 3, obviously that's like multiplying by 10 3 times, and so it's a large number. So anyways, we want to start looking at scientific notation and figuring out, how exponent properties play a role in here. So let's say we have 1.2 times 10 to the negative 3, but the whole thing is raised to the 4th. So we're taking this number and we're raising it to the 4th. Well, if we use our exponent properties, that means that both this first number right here is going to be raised to the 4th, but then also the second number, or the power of 10, is going to be raised to the 4th. So all we're going to do here is take the first number, 1.2, and we're going to raise that to the 4th, but then we're going to take 10 to the negative 3, and we're going to raise that to the 4th. And so if we do that, we can evaluate both numbers. So 1.2 raised to the 4th, I'm going to have to use a calculator on that. That's going to give me 2.0736. But then I can use my exponent properties. So for the second part, right here, what is 10 to the negative 3 raised to the 4th? I know that I can say that this is times 10, and that's a power of a power. So this is to the negative 12th, because I'm going to multiply. So there's my answer for that first one. If you look at part B, now again in these problems, that first one we went through, okay, but I would say pause this, or you can fast forward. Give yourself some time to try some of these problems out on your own, and then you can scroll to or jump ahead or pause it to check your answers. All right. So part B, I'll go a little bit quicker now. If we have two scientific numbers that we're going to multiply, essentially we're going to take this part B and we're going to say, all right, well, this is 3.2 times 1.6. I can multiply these two numbers by themselves, okay, because this is all multiplication and it doesn't really matter which order I multiply in. Then what I'm going to do is I'm going to take the powers of 10, right? So 10 to the negative 5. I can multiply those separately. So times 10 to the negative 5 times 10 cubed. I can really just rearrange these factors that I'm multiplying because multiplication is commutative. So I can start multiplying. So 3.2 times 1.6 is 5.12. And then I can multiply the powers of 10 right here, again, using the exponent properties. So I'm multiplying two properties, two powers of 10. So therefore I'm going to add the exponents. So this is going to be times 10 to the negative 2. That second one. All right, part C. I have 3.8 times 10 to the negative 4, and everything is raised to the negative 3. So what I'm going to do here is, again, if I have a product inside of this parentheses, I have two things that are being multiplied in the parentheses. I'm really just taking the negative 3 and I'm going to apply the exponent to each power right there. So I'm going to have 3.8 raised to the negative 3. And I'm also going to have 10 to the 4th, or 10 to the negative 4th, raised to the negative 3. So when I do that, again, the same thing happens. This little part right here, I can figure out in my calculator. So that first number gets a little bit ugly, right? So if you plug that into your calculator, you're going to get something like 0.018224, and so on. And then my power of 10 is going to be times 10, and I'm going to multiply those exponents to get 12. Okay, so if you look back on this, this is not in scientific notation, technically, because that first number is not in between 1 and 10. It's below 1 and 10. So how do I get that into scientific notation? So what I'm going to do is I have to take the decimal point and I'm going to move it over a certain number of times so that the number that I end up with is in between 1 and 10. So to do that, I'm going to take the decimal point right here and I'm going to move it over once, twice. If I move it over twice to the right, I'm going to be at a number that's like 1.8 or 1.8224. And that number is in between 1 and 10. So I'm going to use that as my new number. I'm going to say that my number is now 1.8224, and I could be as accurate as I want. I could put more decimals there. But now this power of 10 changes. So this is not times 10 to the 12th anymore. But since I basically, this process right here, since I moved the decimal over to the right twice, I basically multiplied by 10 2 times to move that decimal over to the right. So I multiplied by 10 times 10 to make that happen, or by 10 squared. So I have to kind of do the opposite on this side right here, right? So if I multiply by twice over here, I'm going to basically divide by 10 twice over here. In other words, I'm going to subtract 2 from that exponent. So it no longer is going to be 10 to the 12th. It's going to become a 10 to the 10th. And so that one can be a little bit tricky because you have to adjust the first number of the scientific notation. And if you do that, you have to adjust the power of 10 as well. All right, looking at part D. All right, part D, we have scientific notation number divided by another one. So now we just have these two things that are being divided. So really I can break this down into 7.7 over 3.5 times 10 to the negative 3 over 10 to the negative 7. I can really treat the problem as two separate pieces. So the first thing becomes 2.2. And then we go to the power of 10, in which case I'm going to subtract. So I have negative 3 minus a negative 7. So that's negative 3 plus 7. So that's 4. And that one is done. Then we look at part E, kind of similar to part B. We're going to have 2.6 times 6.5. I'm just going to rearrange those numbers. And then I'm going to put the powers of 10 together. So 2 to the negative 2 times 10 to the negative 3. And I can group these accordingly. And I can figure out what each one is. So this becomes 16.9. And then for the powers of 10, we use our exponent properties to add. And this becomes negative 5. Again, we have the same situation where this is not in scientific notation. So we are going to adjust the first number so that we're going to move the decimal over to the left so that this becomes 1.69. And that means in order to move the decimal point to the left, we had to divide by 10 to move it to the left, right? So that means on the right-hand side over here, I'm going to multiply by 10, or I'm going to add 1 to the exponent to keep that value in balance, to keep it equivalent to the one above it. So now this is going to be 10 to the negative 4 because I'm going to add 1 to that. So that's the last problem.